Welcome to this puzzle session. Here is the problem. We are given that each point of the plane is colored either red or blue, and we want to show that some rectangle must have all four of its vertices of the same color. Okay. And as usual, one is encouraged to pause the video and try to solve the problem. And now let us look at the solution. Okay, so we don't really need the entire plane for finding such a rectangle. We just need a 9 cross 3 grid. We'll see why that suffices. So basically just consider these grid points. These overall, I think there must be 27 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 3 the 27. Okay, so we just need to focus on these 27 points. And just note that each of these, vertically arranged 3 points can be colored in at most 8 different ways. So the first point can be the red or blue, the second can be the red or blue, and the third can be the red or blue. So it's 2 times 2 times 2, and therefore in any vertical segment we just see at most 8 different configurations of colors, right? And since there are a total of 9 vertical segments and at most 8 different configurations of colors, by the pigeonhole principle or by common sense, we see that there must be 2 different vertical segments which see exactly the same configuration of colors. Meaning we can find 2 segments, let's say this and that, such that if this is red, then that is red. If this is blue, then that is blue. If this is blue, then that is blue, and so on. If whatever is the color of this, the same is the color of that guy. Whatever is the color of this guy, same is the color of that guy, and so on. So let's say we have narrowed down to such 2 segments. Let's say, let me maybe make it a little bold so that we can see. So So what I'm trying to say is that this vertical segment and that vertical segment, they witness exactly the same color pattern. All right. So now here is the final point. Consider these 3 vertices. These are 3 vertices and only 2 colors are used to color them. Thus, 2 of them must receive the same color, either these 2 or these 2 or those 2. Whichever, let's say for concreteness, this gets the color red and that also gets the color red. Right? One can make similar arguments by whatever is our argument going to be. One can make the same argument if this and that were the same color. We have chosen red for concreteness also. These 2 could also be blue. So I hope that much does not cause any confusion. So let's say these 2 are red. Then by our previous comment, then these 2 must also be red. And we have found a rectangle, all 4 of whose vertices have the same color. Right. So if these 2 were blue, then also we would find the same rectangle. If these 2 were red, let's say, then we would have found this rectangle, all 4 of whose vertices would be red, and so on. So that's the puzzle. Yeah, so maybe I should mention that this can be proved for squares also. One can actually find squares, all 4 of whose vertices receive the same color, but that is much harder than this. Alright, so as usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.